Assalamualaikum and hello everyone. Today we will explore how volumetric analysis can be used to determine the fluoride content in toothpaste, why fluoride is important for dental health, and how suitable this method is for analytical work. Before we jump into fluoride and toothpaste, let's talk about why we are using volumetric analysis in the first place. Volumetric analysis is all about measuring liquids accurately so we can understand how strong or weak a substance really is. In this experiment, we use volumetric analysis to compare the strength of different toothpaste by determining how much fluoride each one contains. And just a small spoiler, one of these toothpaste is secretly a bodybuilder. Toothpaste contain fluoride at about 1000 to 1500 ppm to prevent tooth decay. To ensure toothpaste is safe and effective, manufacturer must accurately measure its fluoride content. In our experiment, we use volumetric analysis, specifically a titration method involving platinum nitrate, to determine the exact fluoride concentration in toothpaste. This allows us to compare different brands and see how well they meet the recommended fluoride level.
So, why fluoride is added to toothpaste? When we use fluoride toothpaste, fluoride works in three ways. First, it stops acids from dissolving the enamel. Second, it helps repair weaker enamel by speeding up the remineralization process and forming fluorapatite, which is stronger and more acid resistant. And third, fluoride reduces the amount of acid produced by harmful bacteria by interfering with their enzymes. Altogether, this action made fluoride one of the most effective ways to prevent tooth decay. Then, volumetric analysis is a quantitative analytical technique where the concentration of an analyte, in this case, fluoride, is determined through a chemical reaction with a solution of known concentration called the titrate. For fluoride determination, the procedure relies on the formation of a stable complex between fluoride ions and a metal ion in the titrate. Here's how it works in more detail. Number one is titrate used is platinum nitrate. Platinum nitrate is chosen because platinum ions react strongly and selectively with fluoride ions. This reaction removes free fluoride from solution in a predictable, measurable way. Number two is reaction between fluoride and platinum ions. Because the reaction is precise, it allows, it allows accurate calculation of fluoride concentration using titration volume. Number three is endpoint detection. The endpoint is the moment when all fluoride ions have reacted with the platinum ions.
Now, let's look at how the toothpaste sample example was prepared for fluoride testing. First, we took 1 gram of toothpaste and dissolved in distilled water. To make the mixing faster, the sample was heated in water bath for 15 minutes. Once the mixture cooled down, we add 4 ml of 6 molar hydrochloric acid. This step is important because some fluoride is trapped inside chemical compound and the acid helps break those bonds so all the fluoride get released. After everything was completely dissolved and the fluoride was set free, we measure the fluoride concentration, use Photolab S12 analyzer, which is it basically tells us how much fluoride is actually present. Now we are at the exciting part, the actual titration. This is where we finally measure how much fluoride is in the toothpaste. First, we take our prepared sample and pour it into a beaker. Next, we add a buffer solution. The buffer keeps the pH at the perfect level so the reaction works properly. Next, we titrate with platinum nitrate. Drop by drop, platinum reacts with the fluoride ion to form a stable compound. The more fluoride in the sample, the more platinum nitrate we need to add. While adding the titrate, we watch closely for the endpoint. This can be detected using a sensor or a color change. Finally, we calculate the fluoride content. based on how much lanthanum nitrate was added.
Publishers' work show that potentiometric titration using lanthanum nitrate can give accurate and precise fluoride results, usually with precision better than 1.5%. However, the reliability depends on whether the monoflow phosphate sample is fully hydrolyzed and whether the endpoint is detected correctly. So, is volumetric analysis suitable? Yes, it's worked well for simple fluoride sample that dissolve easily in water and is commonly used in teaching lab or for quick quality check. But it has several limitations. The endpoint is hard to see, the technique requires an experienced operator, and the precision is lower compared to modern method. Otherwise, the fluoride may be underestimated. Better options today include ion selective electrodes, ion chromatography, and spectrophotometric techniques. So, is volumetric analysis suitable? Yes, it's worked well for simple fluoride sample that dissolve easily in water, and it's to conclude, volumetric analysis can be used to estimate fluoride in toothpaste, especially when the procedure is done with controlled condition with proper sample preparation. However, because endpoint detection is difficult and toothpaste ingredients interfere with the reaction, modern techniques like potentiometry are usually preferred for more accurate and reliable fluoride measurement.
Fluoride versus nanohydroxyapatite. Which toothpaste is better? When fluoride is used, it interacts with hydroxyapatite, which is what tooth enamel is made of, and it actually forms a more decay-resistant material known as fluorapatite. Why is fluorapatite more resistant to acid attacks from bacteria in the mouth? This is because hydroxyapatite begins to dissolve at a pH of 5.5, whereas fluorapatite remains stable until the pH drops to 4.5. The lower the pH in your mouth, the more acidic it is. And acidic environments in the mouth are where cavities happen. So fluoride toothpaste makes teeth more resistant to decay in more acidic environments. For my cavity-prone patients, I recommend fluoride toothpaste. It is better at preventing cavities and it is approved by the American Dental Association, whereas nanohydroxyapatite is not.
A special thank you from the heart